Hi, Faxi Nadu here, and we're back again. Another segment on the modular crash course, and this time we're going to be talking about sequence stuff, how to sequence stuff internally in modular, how to set it up, and what kind of things you can do with it. And we're going to be the patch itself that we will be creating in this one is a drum sequencer with drum modules inside, so like a drum machine that is able to respond to MIDI timing and all that as well. Sequencers themselves talk about a little bit about how you set up the whole syncing to your sequencer and to MIDI timing and how this whole thing works. It will be a little different in different modulars depending on how they set it up. Like it could happen automatically. It could happen the sync. Like you could have maybe a modular that doesn't have all of this and internally has the clock and everything. Automatically receives MIDI and you don't need to make these connections. But this is actually a good way to look and see what happens behind the scenes with this kind of connection. The reason I have it already opened up is because I always mess it up. Yeah, I always forget how it's done, and it took me now just before the video quite some time to make the right connections and get it to work. And there's one thing, this gate OR, and I'll show you in a minute. So what are we trying to do? Over here, a sequencer module, and as you look here on all of these 216 steps on each one of these sequencers. Each one is a different one. They act the same in the sense that they all have these 16 steps that they progress through. Not know by themselves how to do that. They don't know like at what rate to progress, and they even don't know like if you want them to progress right now. Do you want them to be on or off? Do you want them to restart at the beginning? Do you want them to be running or not running? So all this information has to come from outside, and it's coming from your clock source and from your MIDI. Showing you this whole thing to kind of give you a workaround for a problem in scope, and it will also teach you a little bit about the connections. So the problem that we have in scope, that if I set this to external clock and I press play now on the Logic right now, we are on 120 BPM, and Logic is working stably, and there shouldn't be any problem internally in Logic. But if I send it to Scope, you notice right here, and it's set to the external BPM, it's set to Logic's BPM, and it's not syncing absolutely completely. It's jittering somewhere around 119 point something and 120. So it's not a perfect MIDI clock. Workaround that works is to put it on internal clock, put this clock on 120 BPM, and make sure that the location in this sequencer is like the same as the location in the loop in Logic. And that when I press stop in Logic, like let's say we were in the middle right here, if I press stop right here and press play, Logic will restart, right? And I want my sequencer to do the same thing. I want my sequencer that when I press play again in Logic, it'll start from the exact place, from the exact beginning. So it'll be tracking the exact same BPM as in Logic. And this will be our internal clock source, and we've set it to 120, and the same in Logic right here. A couple of other, we can delete this connection. This was just to show you that if I don't have this connection, it won't get external clock at all from MIDI, but we don't need it because we're not using external clock. So let's delete that, not to confuse things. Extending the clock signal to a clock divider, just so we can have tell the sequencer that it's actually 16. It's a 16-step sequencer. So I would like you to progress in 120 BPM, and the progress it should be 1/16th of a note per BPM thing. So it'll be the right progress and the same as in Logic. Okay, so we have that set up with the MIDI clock. So the clock itself is running the right way. The thing that if we had just the clock connected, which would be like the output of the divider into the clock, then the problem would be as follows. If I disconnect this, and this is the reset button, if you notice I'm pressing stop right here. Stop, okay? When I press play, this is now in the beginning, so beginning, beginning, beginning. Oh, and it just didn't reset. It didn't properly go to the first note as it should have done. So you need to connect this to the reset. MIDI note here, because we have clock coming, we have clock that we're not using, right? We're using our internal clock, but we do want to sync it to Logic. So what we have is we'll sacrifice one MIDI channel. Let's pretend channel 1. You can like obviously just use 16 if you're having other MIDI things going. I doubt you have 16 going, so you probably have a free MIDI channel for this. Like a note across the whole time that you want the sequencer to be playing. And then when you press play and connect it this way, it will play. Now the connections that you have to have inside are from the incoming MIDI, which is that note itself incoming into the patch, into an MVC, which translates the incoming MIDI and gives you a separate gate output. One of these needs to go to the clock divider's start-stop, so it will sync. And one of it needs to go to the gate OR into the reset. Now this gate OR, this is the whole thing. This is the whole reason why it was driving me insane. Because if you connect just this one, see it turns on the reset, and then when it reaches it the next time, it'll turn it off. So it holds it. So a gate signal is like, it's a continuous signal, and as long as it's holding it right here, hold the reset button so it won't actually trigger a reset. And you do need the gate up. So this is just the model you need. What it does is it takes the gate and it changes it basically into a trigger signal. And I was going nuts. I always forget that this is what you need to do. I know there is some quirk here, and I'm like, okay, I want to make a sequencer patch, and so I know I need the clock and the divider and the sequencer, and I start messing around with the reset and the clock, and I just can't get it to work. And then I bring out the gate, and it's just not doing it as well. And then luckily, we have the manual for the scope, and this is a good time to show you the manual. Information on every single module, and I remembered I was looking for gate to trigger, and this wasn't working, and there was other stuff. Answers tab, I saw this gate OR, and I kind of remembered that this is the one we need. It's in conjunction with the MVC module, a gate collector which permits the derivation of a trigger signal every time a new note is played on the keyboard. For example, to send a reset to a step sequencer module whenever a new note is played, causing it to restart its current pattern. So this is exactly what I was looking for, and yeah, thanks. And every time I get reminded, but this might happen to you as well. So just to remember that you need this one in order to get this working. And what I suggest actually is to have yourself like an init patch. Save yourself a patch. Something like this. I just added a high pass and a multi-effect. You don't need this, but save yourself this kind of mechanism. Sequencer starter. Not sequence thing is you already got. You just, instead of loading an empty modular, just load up this module, just load up this patch, and you're ready to go. So again, at the ones that I deleted, let's pull them out. You have two kind of groups of sequencers. You have one, which is here, the MDS8. It outputs basically gate signals to drums, which you will see, and we will use this one. So this one we will see. And then you have here, group and a different folder called sec sequencers, and you have different you have a control sequencer. You have different types, but let's say the control sequencer will have unipolar and bipolar. Well, let's check it out. polar and bipolar control sequencer, and you have sequencer, two types, and of course a pitch sequencer. Oops. So you have all this. Use for this patch the drum sequencer just to show also drums inside the scope system. So we have this, and let's reconnect that god awful gate OR, and let's connect the clock. Press play on Logic, it'll reset, be in sync with Logic, and same BPM and the same spot. So we're good to go right now. What this one is basically, as you see, it's a 16-step sequencer like we mentioned, and you have eight channels on this sequencer. They're just labeled bass, snare, whatever. It's just text. You can erase it and write whatever you want. Matter. 3, you can whatever you want. And they have like each input corresponding output. So 1 would be 1, 2, 3, 4, 5, 6, 7, 8. Simple enough. You can do other things like in this sequencer as far as you have patterns inside. You have a ton of patterns, so 32 pattern sequencer. So you can actually draw many patterns, and we'll get into it a little bit more. Like you can use this actually not just for one pattern, but like for a song, for sequencing like an actual song inside. So let's move back to pattern 1 for a second though, and build a drum patch before we get thinking of songs and stuff. So what kind of drum things do you have in scope? We have various drum oscillators that are from Sonic Core themselves, and we have some third-party stuff, and we're going to look at some free third-party stuff. So let's look first at the Sonic Core drum folder. Drum OSC. Hi-hat source. Perk OSC. Sample drum oscillator. So there's a few options. If you look at the perk OSC and then the perk OSC, the drum OSC, and the drum synth, it's basically just progressively more elaborate versions. So this would be the simplest one. This would have more things on it, and then yet more things on it. The two different ones would be the drum sample oscillator, which is it's a sample oscillator with an envelope on it. So with like a short and responsive attack, hold, decay envelope. So you can just load drum samples in here, and we'll do that. This is a hi-hat source, and there's no enveloping and no decay, and this one works a little bit differently, and we'll save this for last. Like I'll show you how to use this as well. So let's start with let's delete the drum OSC and drum synth, and keep the one that they call the perk OSC, the simple one. And for me, it's a very usable one. The other ones are nice, but you can get really cool and weird drum sounds out of just this one as well. We have Logic running. Obviously, just remember, Logic is only sending the sequencer when to play and when to reset and timing. So this MIDI is not actually playing anything into our drums. It's this sequencer. Output number 1 into the MIDI inputs of the drum, and now the drum is receiving these gate signals, these notes, sending it. We have 8 channels. Let's already take out a mixer that can mix 8 channels. Polyphonic mode. Obviously, drum channels are polyphonic channels, so our whole patch is going to be monophonic channels. So our whole patch is going to be monophonic. So we're changing this to single mode, and this means it's green, and it means it's monophonic. The drum, the perk OSC to the first connection, and let's connect it to. I've put a 24 dB high pass filter right here, but it's open right now. I wanted it maybe for later. Sound going, it's a little low. Where did it go? Where is our modular? There we go. And already it's a pretty cool kick drum, right? It's a nice start for a kick. And you can mess around with all the controls. And it's a really cool kick synth just right here already. Clipping a little bit. And you can get that clipping nicely, actually. It's distorting in a nice way, like a gabber kick. So you can get really all sorts of kicks here, and they sound pretty good. So let's keep this. I'm going to mute it for a second while we add one more. So let's add another, the same one, a perk OSC. Obviously it's channel 2 now. First one quiet for a minute. Play notes, and it'll play the second channel. Just go kind of semi-randomly, you know, just to make an example. So now if we play both channels, they're the exact same sound, aren't they? So what if we have one of them, let's keep them similar, but change one of them just a little bit. Now isn't that already pretty cool? Yeah, not bad at all. So let's keep both of these. And let's add another perk OSC. So I'm copy pasting. Make it quiet. Let's have this one do, you know, let's get away from that kick type of sound. I just want to show you already, there are some actual presets on these. If you click P, points for quite a few things. It's mostly for have a lot of bass drums, variations like on the sound that we did just now. Sounds and some perk sounds. So why don't we do this? Why don't we like on every other one? Then we have a little variation. Let's do that, like I drew now. All of it. But let's open the presets and kind of check out what they have going. Yeah. I'll take it. What about one more? Okay, so we have 3 channels already going. This will be our 4th channel. Let's do every single hit. Ambitious with this one. You may have noticed, okay, look, when I draw one, it'll draw a gray one, and then if I click it again, like it'll become orange, and this is like an accent. It'll make the volume a little louder, and I'm not sure, maybe the decay a little bit more open. We can just hear it in a minute, and it's another way to get dynamics into these drums. So if you click once, it's the normal volume. This is accented, and then the 3rd time we'll delete it. The normal volume right now. So this is the 4th channel, and then wrong button. Now obviously 3 and 4 are the same now. Let's go back in there. Let's look for another percussion. Let's hear some more. Let's look for something really narrow. So how about that? Not bad at all. So we have 4 channels of that going on right here. Let's use the sample. Let's say we got like two kicks. So we have like a kick bass kind of thing going on, and then we have like those percussions going on, like the mid to high kind of mid range, I guess. Let's bring in some hi-hat, and let's bring one with a sample and one with the hi-hat source. So let's start with a sample. Okay, programs. No, it's just, wait. Go into my samples, and I have some very typical 9 and 808 kind of samples, and there should be one which is can open hats, and I think it can it's this one. It's this one. Place it on number 5. Get like an offbeat hat. 11. There we go, I think. Yeah, is it right? 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Yay. Okay. Let's see if it's playing at all. Yay. Nice. Let's keep it here. Let's do this. Let's make it organized like this. So, or you know, like this. And you do have envelopes, so you can. Not bad at all. So yeah, let's keep that as number 5. Have closed hi-hat, you know, on number 6. Should we have it like, I don't know, maybe like with the kick? Or some, yeah, let's have it running. I'll show you how, like, yeah. So ask if you just connect it to the mixer. Let's connect it like on really low because it's a running mix of white noise oscillators that are detuned from each other. So you can take either the OSC sound, the noise sound, or that mixed sound. Let's use that mixed sound. It's like the bottom line is it gets you a metallic sort of sound that is great to use for a hi-hat source if you put an envelope on it. But it does not have an envelope of its own on it. So we're going to take a VCA, and we're going to take the vintage envelope. NMOD. NMOD means it has these inputs, and you might be familiar with them from other videos, and we're going to use them here. And then, does it make this connection? No, it doesn't. So let's see if we can do it this way or not. I think because this is outputting MIDI. Okay, yeah, you can. You need the MIDI to trig, I think. This. Well, it wants gate. Let's check. Let's check if it works. Here, I'm not sure it works yet, but this is part of the experimenting. I'll tell you what I'm experimenting with. This outputs MIDI. It doesn't output actual gate. The drum asks themselves. They know how to translate it to gate. Our envelopes, they want gate signal, and it's not the same as what this is outputting. It needs something to tell it that this MIDI signal is stripped down to a gate signal. Okay, there's another way to do this. There we go. So my bad, I remembered. Yeah, there's so many modules, you know, you'll be going like this yourself. So this should do it. Let me just make sure that it does. And This is our envelope that is going to control this this non-harmonic sound coming out of the hi-hat source, so-called hi-hat source. Yay! So it's working. Cool. Yeah, this is how you do it. So yeah, it's fine. That MIDI to trig that we took out, it's possible that it would have worked as well. It's possible, but let's not dwell on that. We got it to work and we're good. So it works. And now we can do another thing to show is that like traditional drum machines, you know, we have our two hi-hats. So we want, well, they're both short, but we want, when the open one is playing, we want it to mute the closed one, and we want the closed one to mute the open one once it's playing. This connection here, and I think it goes like. Try, I think this should do it. So let's test this by making a really supposedly really long envelope on the small hits, but they should get muted once they hit that one. So let's check. And they are. Awesome. So it works. And you can actually do that. We can actually make that, like, try doing it with the kicks. I'm not sure that in this particular case it's affecting. The decays might be like too short, but let's keep it this way. So when the different kick sounds hit, they don't interfere with each other. Yeah, it's pretty cool. But the open hat sound is, I don't like the sound itself. Let's see what we can get out of it. You know what? In this case, or do you want the asks as well? A little bit. I don't know. I don't want to use the asks now. I wanted just the noise, so I don't need that. I don't need that module, right? We've seen that there's just a noise module. And that'll serve me just as well, and I will filter it to get the sound that I want. I'm thinking high pass, and then maybe even band pass. Yeah, this is more like. And I want to do one more thing with this closed hi-hat sound. As you've seen, we've taken out the AD and mod, and the N mod allows us to have modulation on the attack and the decay. So we're going to modulate the decay. I do this often. And for that, we're going to need, I want to sync LFO. I want it to be like on the beat, the different hits to occur on the beat. Use the MIDI clock that we already have, but we need a frequency divider. And here it is. And 15 steps, we can change it in a second if we want to. Let's see how it sounds like. The decay to bring back the beat. Pull up the decay modulation. Awesome. Cool. Very, 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 very cool. Let's do more. Let's do more. So um, let's kind of try to move around our kit. I want to kind of clean it up, but we've made a mess by using so many modules on this last one. So, but I get yeah, like this. Let's do it like this. Let's place it like this. And we know we have two more, right? So we have 7 and 8 available. And let's bring another sample oscillator. And let's have this one be sake of example. Let's have a crash sound in there. And this will be 7. So let's play it again. So it didn't end up exactly like a crash, but it's cool, so why not? Yeah. It's like weird crash. You notice that on the sample oscillators you have coarse and fine controls, pitch controls, and you can kind of screw up with samples really nicely with this. Kind of messed up their pitch. And what else can we take? Let's take one more of these sample oscillators just for fun. Some like sound effect maybe. Sample stash. One sound effects, just effects. I don't know. You can find something that is randomly kind of cool for this. Not too long. I don't know what this one is. Let's check it out. So and then let's play and add MIDI. There we go. That's cool. So you already have a really cool drum machine like this, and you can save it like this, and you can use it like this, and it's really cool. You can have MIDI controllers, like on each one of these. You can assign each one of these to a separate MIDI knob, and then you can mix them live, you know, in and out of the mix. You can save patterns and actually play different patterns from this, and you can use this like really much as a live performance tool or as a studio tool. You know, you can make really cool loops like this one and record them. But I think like this, as it is right now, both for the studio and for live, it is a bit static, right? So let's add some filtering and some more stuff. And I'm going to take a sip of tea right here while I bring out some filters. Let's start with let's first of all let's make our patch bigger so we have more room to work with over here and add modulators and stuff if we would like. Start with, let's take this one aside. I took out a comb filter and a ladder filter. Let's put this one aside for a minute and start with the ladder filter. The ladder filter is basically just it just implies that is the same design as like the Bob Moog's filter. It's a Bob Moog type of filter, which is like a 24 dB octave low pass filter, and supposedly with the same kind of response and sound and feel of Moog's filter. So let's just try connecting this. So let's have some of that going on. Let's bring out more LFOs. Switching everything to single mode. Doing this, we will use it later. LFOs, where was our, there we go. So we have 2 LFOs that are synced. Let's give him also this gate. This is the gate that tells the loop when to start. So we're going to have the option of having the LFO also start its run according to the loop itself. We can turn it on or off. Let's keep it on for a minute. Or no, you know what? Off, and I'll show you. This one, that long sweep that I did by hand was kind of nice. So now it's sweeping it really slowly, 0.01 hertz. And we have already movement and dynamics. Let's bring in this one, and we'll have the second LFO like on the BPM and doing some crazier stuff. Keep it or not, let's see. Not bad at all. I want just to have the option of smoothing this controller. So that's the trick I've shown before, is when you take a stepped LFO, inserted it into a 6 dB low pass, it creates a sort of a glide. Let's do that. Let's see if it changes. Yeah, too much. And obviously you can So let's keep this filter, and let's now bring in that. Let's bring in that comb filter. And put it right here. So let's go from the ladder filter into the comb filter, and I want to show you this one just because it does like really crazy things. There are two types of comb filters in scope. Well, at least the stock ones are like comb A and comb B, and they just have a different type of combing effect. And just listen to them both, like interchangeable. So one of them is like tighter combs, and one of them is narrower, and one of them is wider, basically. So what it does is like a really short, and this gets crazy. So, and you damp it. It can create it can create strung instruments. You can use this to create like stringed type of plucked sounds, but we're going to use it as an effect. We're trying to just affect these drums and make them sound wacky. So wouldn't it be cool if it jumped around like that? Definitely. So we're getting another LFO in there, and again it's on step. And we're going to put it on 1/16 and just listen to it for a second. And let's smooth that control. And here that high pass that I've put in the way in the beginning would come in handy. So, yeah. So it gets really cool. Now we also have another, if you see, another modulation input on this comb filter. Let's take out a sine LFO. Over time, changing the comb filter. And what it does is it slowly, this one is changing it really fast, right on the BPM, on like the whole thing, on sample and hold. So it's taking random values each time, and it's really going crazy. This one is just going to move it. So this is like the original spot. So the sine is moving like, but I don't know how much it will respond, being that this one is open all the way. But let's see if it does something and how much. So not really. So maybe let's take another approach. Add a degree of randomness to it with an unsynced LFO. Or let's try audio rate. Okay, so let's not use it. I give up. Let's give ourselves the option, though, to have we suck it into the comb filter. And we might like the comb filter, but it's, of course, gives it a really, really kind of distinct sound, a comb filtered sound, and you might not want it all the time. And you have built like this huge, awesome machine that you don't want to maybe use just for comb filtering. So what we're going to do is we're going to add the option to just have both of these. Just the ability to either bypass the comb machine, sorry, the comb filter, or keep the comb filter. So this is simple enough. It's just a matter of applying the right switches over here at the end. Delete the comb filter from going outside, and we're going to take one signal before comb filtering and one that is the output of the comb filtering. And you know what? Instead of using a switch, let's use a crossfade modulator. It'll add even more color. If we want to go nuts, we can go even more nuts. And you know what? We'll use, yeah, okay. So let's put the left side without the comb filter. The right side will be with the comb filter. We're going out into the high pass and outside. So if we play it now, I'm just taking off the cables. So what if we want to have the option to evolve over time? Let's take this sine LFO that is connected here, but it's unused right now in our patch. So let's just use it for another thing. Let's connect it to the modulation input of the crossfade and have it modulated all the way. So it'll go, let's see. It'll go from one side and blend it with the other side, hopefully. So we have many options. We can make it interesting in many ways. We can use different tones. We can use a tone that is without the comb filter. We can use a tone that is with the comb filter. And we can, of course, also just open up the ladder filter and turn off the modulations. And that's fine too. You can mix any one of our 8 channels in. We can change samples. You can do a lot real time with this, actually. You can probably use this particular drum machine pretty well for a live show. You have a ton of control. You know, you can change the sounds. You can actually save your own presets. So I've shown you that there are like factory presets, but you can also save your own sounds into these banks for quick loading, even though it's really simple, but it's for quick loading. So you can load different, like make a kick and load it in different songs that use different patches, but the same kick sound that you've programmed already. That's very cool to use. So here you have a little bit of a sense of how to use the drum modules and how to use the sequencer modules. Let's do one more thing. Let's open up another modular. Show you that there are a lot of third-party modules as well. At them, there's like a clap module and here a kick, and look at this, a lot of parameters and a nice GUI as well to these. Then there's some more in this one. And then there's a really nice one that is called Analog Drum 8. And basically it's there's like 4 outputs here. If you click it, if you open it, see? All of these, each one is a different drum sound, parameters and things you can do. kind of less in the modular sense. I mean, you just send MIDI and then send it out, but available on the modular and it sounds cool. So drum options, and it's very easy to make drum oscillators, kind of drum sounds of your own. You know, using sine oscs and noise oscs, and some of that you've already seen in this one. How we just use pure noise to fake. Well, to fake, it's not really to fake because anymore today, because I was going to say to fake a hi-hat, but so many hi-hats in electronic music today are just this kind of hi-hat. They're just like noise oscillators. So thanks for having a look, and we're going to do more sequence stuff in other videos. So stay tuned for more sequencers, and have a good one, and catch the next video coming up. See ya.